All right, let's talk about cracking the GRE. Specifically, we're going to tackle a part of the math section that, honestly, trips up a ton of people. It's that very first question type to hit you with. So let's dive right in.
So, you want to know the secret to acing GRE math? Well, here's a little hint for you. It's actually not about being some kind of human calculator. Nope, it's all about being a smart test taker, and that starts the second you hit that very first question.
Okay, let's demystify this thing. We're going to face the first big challenge of every single math section.
And here it is. The first, say, 7 to 9 questions you'll see are this really unique type of problem. They're called quantitative comparisons. And they really do look and feel different from everything else, and that's because they demand a totally different approach from you.
All right, so let's get into understanding quantitative comparisons. You gotta know the rules before you can play the game, right? Let's break it down.
So what is a quantitative comparison, or QC question? Honestly, at its core, it's super simple. You get two things, quantity A and quantity B, and that's it. Your only job is to figure out the relationship between them. Is A bigger? Is B bigger? Are they the exact same? Or is there just no way to tell for sure?
Now here's something that is a huge advantage for you. These 4 answer choices you see here, they are the only 4 answer choices for every single QC question. A is always quantity A is greater. B is always quantity B is greater. C always means they're equal. And D means you just can't figure it out. You need to burn these into your brain because they literally never, ever change.
Okay, but here's the catch, right? You only have about 1.25 minutes per question. Think about that, 1 minute and 15 seconds. That's just not enough time for some long, complicated calculation. And that's actually a massive clue. The test itself is telling you, hey, don't do a bunch of heavy math here. Which brings us to our first big strategy. We need to work smarter. This isn't about calculation, you guys. It's about comparison.
Seriously, make this your mantra for this whole section. Do not perform more calculations than are necessary. If you find yourself hunched over your scratch paper scribbling out this long, messy equation, you need to stop. You've probably missed the shortcut. Remember, the goal here is to find the relationship, not the exact answer.
So, how do we actually work smarter? Well, we've got 2 main ways. First up is approximation. Basically, just get close enough to see which side is bigger. No need for perfect precision. And the second way, compare the quantities in parts. Just break the problem down, maybe cancel out the stuff that's the same on both sides, and only focus on what's different.
Okay, check out this example. It's perfect. So instead of plugging in 3.14159 for pi, who has time for that? Just think of it as a little more than 3, right? So 3 times 25 is 75. That means quantity A has to be just a little bigger than 75. And a lot of the time, that's literally all the information you need to get the right answer. So much faster, isn't it?
But what happens when the comparison isn't so obvious? Well, that's when you need to get a little more hands-on. This next strategy is all about how to test and transform. This is your toolbox for those trickier comparisons.
So there's this really cool thing called matching operations. Think of it just like balancing an equation in algebra class. You can do something to both quantities to make them way simpler. The golden rule, though, is that whatever you do to one side, you have to do the exact same thing to the other. That's the only way to keep their relationship the same.
So what are the legal moves here? Well, you can add any value you want to both quantities, you can subtract any value from both, and you can multiply or divide both quantities by a, and this is key, a positive value. That one word, positive, is probably the most important detail here. Don't forget it.
And this leads us to a huge, huge warning. Seriously, this is one of the most common traps on the entire GRE. You cannot multiply or divide both sides by a variable unless you are absolutely certain that variable has to be positive. Why? Well, think about it. What if that variable x, or whatever, is a negative number? Multiplying by a negative would completely flip the comparison, right? So unless you know for a fact it's positive, just don't do it.
Okay, here's another powerful tool for your toolbox, especially when you see variables. You know that feeling when you're just staring at x's and y's and the algebra is getting you nowhere? Just shift gears. One of the absolute best things you can do is just plug in your own numbers. It takes something abstract and makes it totally concrete. Now, plugging in numbers, it's got a big benefit, but also a pretty big drawback. The good news is, it's great for eliminating answers. Let's say you plug in the number 2, and you find that quantity A is bigger. Boom, you now know the answer can't be B or C. So it has to be either A or D. But here's the catch. One test is not enough proof. You have to try a different kind of number. Try a negative number, or a fraction, or zero. If you get a different result, like now quantity B is bigger, then you know the answer is D. If you keep getting the same result, you can be pretty confident, but it's not a 100% guarantee.
Okay, so when you put all of this together, you can see this is about more than just a couple of tricks, right? This is about getting your strategic advantage. It's about a complete shift in your mindset for success.
So, the most important takeaway for GRE quantitative comparisons is this. If you walk away with just one single idea from our chat today, I want it to be this one. Strategy trumps calculation. That's it. Every single time. The quantitative comparison section is not a math test in the way you think. It's really a test of your logical reasoning and your strategic thinking.
So let's recap your QC toolkit. You've got your work smarter moves, approximating and comparing in parts, and then you have your test and transform tools, using those matching operations, and when you need to, plugging in numbers. This is what you bring to the fight.
Look, by focusing on these techniques instead of just brute force calculation, you're not just solving a math problem. You're actually solving the test itself. You're playing the game on their terms. So really the only question left for you is, which one of these strategies are you going to master first?